Hi, hi. Can you hear me?
Hi. Yeah.
Yeah, yeah. So, um, have you used installed XSpec? So you have installed yourself, right? Hello.
Yes, I can hear you now.
Hmm.
Yes, I have installed XSpec and I tried a bit of very basic stuff where I loaded data and
Mm-hmm.
plotted data. But beyond that, so basically I want to try and fit a model, which uh, they have given a set of instructions in a couple of sources, but
Hmm.
uh, I don't know how to tweak them in the right way for my data and be able to plot uh, fit the model.
Okay, but the point is, every kind of source is a little bit different. So what I work on extra binaries. So there will be a spectra file and a response file and a background file. I think this is
Yes,
same for your case also. But
yes.
exactly which model fits it, it's you have to check it. Like you have to try different models, and or maybe you have to first understand the physics and use different model according to that. So
Okay, now so for this given source, so uh, so the guy who gave me this source to try out on, he has asked me to fit a simple power law model to this.
okay,
So I mean, at least the model is clear, but I don't know uh, to tweak the parameters in the
okay, yeah.
correct way to fit the power law.
Oh, I understood. Yeah. So you want me to go through the basics, or directly want me to just show you how to adjust the parameter?
Uh, so what do you mean by what would be the basics?
The basics is you already done that thing. You have already plotted the data and set the log. See it in a log. How to see this plot in a log format, log format, things like that. You already know those things, right?
Uh, okay, so I know the basic plotting. I don't know the log. So I tried. I think there was a log plotting command,
Hmm.
but I couldn't interpret it well. So I think the errors show up differently in the log plot, right?
Uh, uh, yeah. The plotting will be different. The and error actually. After fitting your model, you can see the error. Otherwise, what's the error? Let me just
Okay.
give you a brief idea. Okay. So
Okay.
here I have the background file for it's a spectra of a binary star, sorry, binary extra binary system, and this is the spectrum file and this is the response file. So um, you know how to load data. It's DA, and this is the spectrum file.
Okay, are you sharing screen or?
Oh, sorry, I forgot to share the screen. Yeah. Just- Yes. Can you see the screen?
Yes.
Okay. Sorry, I forgot. So, now to load the data, its command is DA and the file name. If you want to put multiple spectrums, say, then you can also put multiple spectra. Like then you have to do this data one file name, and after that you have to put the two two colon two file name like this. Okay, then it will take, it can take multiple spectra. uh,
Okay.
then this command will lead you to the plotting device, cpd backslash xw, and now if I plot this is in channel number and normalized count rate. So if
Yeah.
to see this in energy, I need to set PE, then it will plot in energy, and this count rate is in normal scale. Change this, you have to PL log data LD, then you can see this in normalized count rate in log scale. Okay.
Okay.
Okay, then this so this my yeah my the data is good in between this 3 to 50 kV. So I have to remove the phase bin before that and after that. So command is for that you have to do this thing, ignore. It will basically remove the channel from my 0 to 3 kV, and also I want to remove from above 50. So 50, yes. So it will remove all the channel after 50 kV. So now if I plot it, then this is the spectra.
Yes.
So is it look similar in your case also?
Uh, it is a bit different. So the energy range is sort of the same, but the shape is different.
Yeah, sure, that could be the thing, because the object is different. So now you want to fit a model on top of this data, right?
Yes.
So so if you know what model it has, you can check like this mo question mark. It will give all the available model. These are the available models. These are the some additive models. These are some multiplicative model, and these are some convolution model. So what do we want to add? We want to add a power law model. So how so for that you will simply type AMO, and you will write POW. So you can also write power law, I guess. I think it is somewhere here. Um, I don't, I can't see it here, but it will work. So now I'm adding another component, TB apps. So this is an absorption absorption hierarchy model, and I'm multiplying with power law model, and it will ask you for initial parameter. Okay. uh,
Okay.
so so if you can default, if you can choose default setting, just need to press enter, and here you can see the model TVFs into power law. And this side, this is the initial parameter. I haven't fit the data yet, and you can see the chi-square, reduce chi-square value here. So our goal will be reduce this value to around 1. So that is generally accepted here. So if the reduced chi-square is around 1, then we say that our fitting is good. Otherwise we uh, uh, use some different model and try. So let me just see. So now I'm doing right this. So PLLD del. This will this up to this same. This is plot log data, and del is this. So model minus our model minus the original spectra is this second panel.
Okay.
Okay. So now if we feed the data, it will be obviously a poor fit. Now see this line is after fitting the data, after fitting the model to the data. Okay. So now you can tweak this parameter also like this. If you want to say, if you now you want to change the TBFs to say uh, 2. So how you do that? You will do that by typing NE parameter number. This is the parameter number. You have to type the parameter number and your desired value 1. So say I want to fix this 18 to 1. So it will now if we show this, you can see it, I fixed this value to 1 again. Can you see that?
Yes.
Okay. So sometimes what will happen is that number may go some may very high value, so this is not desired. So you can also fix this value. So either you can type fr freeze parameter number 1, then show it, then this parameter is frozen. Now if I fit the data, this parameter will not change. It will fit only with these two parameter, not with this parameter. And if you want to
Okay.
unfroze it, you will write thaw, THAW, thaw parameter number. And if you again show it, then it will it's frozen, not frozen now. Now if you fit it again, it will change to some values. So um, so depending upon your source, you have to play with this parameter, add more models to it. So suppose you want to add another model here. After how do you add that? Do that, you will add a new component at C. Say you want to add position 2. So here you will type the position number and the model name. Say I want to add another model which is very popularly used in X-ray binaries. So it's high cut. So again you can see that this is a multiplicative model. So it has went into here. So again you can fit it. Now our chi-square value is a little bit better than before, but still we have this feature here. This is so depending. So you have to always check that. So I I suppose that there may be a line energy here. Then I can add a Gaussian line here. There is a deep. There is a deep. This can be so depending upon this residual. This called residual. You can add or delete some model. So you have to try with different models and try to reduce this chi-square value. And yes, this is the basic thing. So can you share your spectrum file with me?
Okay, wait. I will email you. Uh,
And another thing, another quick thing, another just to save the plot. So this is the basic thing you'll need to use. There are a couple more things, a couple more comments. So um, if you want to save this plot, so you have to go write IPL, uh, and it will take you in a plotting device, and then you can save this, say age, file name. So it will save this in a PostScript format. And another thing is, yeah, if you want to save this save this, say you want to save this, save your work up to that. So you will save like this: a save all, save all, some name .xcm file. And if you want to load this exact same file, you have to write @name .xcm. It will load the previous work. So yeah, this is the basic command that you need to know at least. Hmm. So can you share me your spectrum file?
yes, just a minute. Oh, can you tell me your email ID?
Yeah, it's let me write it. Yeah, I have sent you my email at Slack.
Yeah. Okay. I sent you the file.
Hmm. But I haven't received it. This- I can also yeah. Hmm. Yeah. So this is the source file. This is the source file.
Yes.
So so what energy you have to choose?
Uh, Around point 3 to 50, say. Or maybe point 0.5.
So the spectrum is only up to 20 keV.
Oh, yes. Okay, is this a log plot? No.
Yeah, it's a log plot.
Oh.
So,
Yeah, till 20 would be fine.
so you don't know the energy range? So you know the channel
I,
number, right? So do you know the channel number?
yeah, I think 20 would be fine.
20 keV. Okay. What is this line? Okay, this is the model. Some
Can you check in the normal plot? I'm not sure about the energy range. In the normal plot, maybe you can
no,
see.
a normal plot means channel number.
No, I mean, not a log plot,
Okay. Uh,
linear.
hmm. Just ignore this thing. I don't know how to remove tail. C 1, 2, 3. Yeah, but C 2. Let me start fresh. Yeah, yeah, now tell.
So point 3 to in this, so till channel 2000 would be fine, right?
Yeah, I think so. But after, I think after 100, 200, 300, no, it's 200, 400. After 350, I think the data is going, it's not that good. I don't know actually. So whatever, you can check that somewhere with up to which channel you have to use. So you can ignore that accordingly. So generally what people do, people plot this in log, at least for binaries. um, so you can ignore the from there, I think. Ignore some channel 10, ignore 10 channels. Still there is something here, so I need to remove.
You can ignore, I think, say 100 channels, or no, would that?
Yeah, it's removed. And now you have to do the same thing for the right part, right region. So I think 100, after here the spectrum is going bad. So you can remove from here. So it is around 1200, 1400,
1600.
1600. So you, no, 16. Yeah, this is the spectrum. In plotted in channel versus count rate. So now you can change the channels to say P E energy. This is in KV. So if you want to add a little bit more of more energy, then you can also do that. Now if you want to add some model, say you want to add power law. So you want to add power, anything else? You just want to add power law.
No, just power.
So model power law, and you want to see the residual. So you will write PLLD del. So this is the residual part. So I just type fit, and this give me this line. So here there is data is going. So it is overestimating. Sorry. It is overestimating, and here it is underestimating. So you have to add some other model to take this into account. Like you can add some black body to cover this region. Um, so you do know which kind of model they use for this source?
No, I'm still learning the science of
Just
regions. So
okay, but you can always go and look what other people do with this kind of source. I actually don't know also. Like yeah, I'm also new to this. So you can add some black body component. Say suppose you want to add a black body component. So you will add like add C number 2. It's and black body will be a multiplicative component. Multiplicative means that this is a uh, emission model, power law model, and if you want to add a multiplicative model, that means uh, how do I put in, like uh, so there are other model. Just so black body is a additive component. So this is a energy emission mechanism, and this is another different energy emission mechanism, like the emission mechanism. So it's a additive component, so it add up. Sometime you want to say, now you want to see what's the absorption. So now you want to add some absorption column here. Maybe say there are some neutral hydrogen atom in your line of sight, so you want to add a absorption component. So this will be a multiplicative component. Do you get it?
okay,
Yeah.
yeah,
So let's just see what it gives. So if you want to fit it, um, so yeah, black body component helps a little bit. Reduce chi-square is around 6 point something, so it has reduced a lot. Still, maybe there are some broad feature here. I even in here also. So you have to add accordingly. Generally, there will also absorption column, normal neutral hydrogen absorption column. So you can add it. Add C. Yes. You can find out this model in the XSPEC manual. So just see what model people have used. Power plus. So yeah, see, adding an absorption line work. So it is much better. It is around 1.14 now. The plot is good. Mm. This is how we
Okay.
do it.
Okay. So basically, we need to have some idea that what all might be the models.
Yes, yes,
Uh,
that you have to know.
are. Okay.
So
And
how
so,
I can
the,
tell why I would use black body. So it after it, so if I now just remove the black body, let's say I want to remove it, del C 3, and just after without fitting, I just plotting it. So now see that there is some extra. Uh, so it went up little bit. It went a little bit up, right? So that means there are some extra emission at low energy range. That's why I added a black body model. Um, and I added this TB absorption model because due to our line of sight thing, like it's a model for neutral hydrogen atom. Okay, that's the thing.
okay.
Now it work without black body. Wow. I don't know what to
Oh,
add, what model to add, but you need to play around this.
okay. And so, is it advisable to always work in the log scale, or I mean, what is the main difference in linear and log scale? Or
I think if we plot this in shift tail, so here you can do without log scale also. I don't know actually, but yeah, you can here you can do it in log without log. In your case, this looks like,
okay,
yeah. I don't think there is any particular advantage, but I always do it in log scale. At least energy wise, it's useful to set this X channel in energy, but in count rate, I'm not sure why people use log scale.
okay. So one problem that I was facing
Mhm.
was, so when I started fitting the model, it started saying that uh, something covariance is 0 or something. I don't. Wait a minute. Let's see if I can get the error. Okay, so I got a warning that chi-square may not be valid due to bins with 0 variance in spectrum numbers 1. I didn't understand what the warning was about.
Hmm.
Do I
I
need to
also
bin
don't.
data, or is it not really necessary?
Uh, what was the problem again?
So it showed a warning that chi-square may not be valid due to bins with 0 variance.
Okay.
So
Did
it
you
still gave a
ignore those parts? What I did before.
which one?
In the beginning, I ignored some data, na.
Yeah. So I I took some from the, I think my range was a bit larger than this. So basically, is it range dependent that if I take a good range, then such a warning does not show up? and if I take bad channels, then it can.
Probably.
So it gave me a chi-squared value anyway,
Mhm.
but uh, I mean it just showed up as a warning.
Maybe bad energy being means the error is high. Probably that's why. I don't know actually. Probably because of that, but I'm not too sure.
Okay.
But I will advise you to which which telescope is this?
This is wait a second. This is, I'm not sure. I think New Star or XMM maybe.
Okay, but they will have some valid energy range. So check that and use that energy range as your
Okay.
in your fitting. Hmm.
Okay. So basically telescope dependent. So
Yeah,
in what range the telescope operates.
yeah, sure. Like in Lax PC, what I work on, it's the energy range is valid from 3 to 80, and it specifically mentioned that after 50 kV, the spectrum is not reliable. So I usually remove after 50 kV. I don't take into account the whatever the spectra is. I don't take that as a science data. So I just remove it after 50 kV.
Okay.
So it's telescope dependent.
Okay. Okay. So after we get this, I mean, is this the end of data analysis, or what do we do next?
Mm, yeah, probably this is the end. So this parameter will be important. So whatever the parameter is here will be important, and this chi-square value will also is also important. It is you have to reduce this chi-square up around 1. So then you can say that your fitting is good. Yeah, I think this is the
So
end of your
what is the acceptable value? I mean, around one is, so one is the ideal value, but
yeah.
what
Let's
is
say
the,
point 9 to 1.23 whatever, like. And if you see the residual is looks quite okay, like here there is not much problem with the residual. So I think in the initial here, if you add black body, this thing will go away. uh, so if you see a good residual here and a good chi-square here, then you can say that yeah, our plot is our fitting is done basically. And
okay,
now you can save all of your work. Showed you before, na? Save all some name xcm file ka name.
hello?
Yeah,
Yeah, yeah. So what were you saying?
yeah, I was saying that so you can save your work up to that, like writing save all some file name dot xcm. Okay,
Okay,
so next time you can start from there. If you just say you want to add some other model and see what happens, you can save your work.
okay,
Yeah, this is the basic plotting. Even you can add some multiple spectra. I showed you before, no? Data 1, data 2, like this.
yeah. Okay, and one more thing. So I haven't reached that stage yet, but it is, I mean, it is the ultimate aim that I have to I have to take data for a given object and fit two different models to it, and then compare them. So, uh, I mean, will I have to do it differently, or can I do it? So right now we have loaded the spectrum. So
Yeah.
can I fit two models to it right away, or should I do it in separate?
Uh, I think it can be done, but I'm not sure. But I can show you another trick to save your model, not save all of your works. You can save your model also. So say you took a same spectra and want to try different model. Okay. So what you can do, you can save this. I want to say I want to save this particular model, say TB apps into power law. So I will write model, some model name, um, one dot mo, I guess. Model name. Forward. Just a minute. Just give me. So you can save two different model and check their parameter. I don't know how to do it together. Yeah, exactly. I don't know how to do it together, but you can do it separately.
Okay.
But just wait a minute. I'll tell you how to save a model. Oh, sorry. Save model. Hmm, forgot. Yeah, save model file. Did you see it? You see it?
Yeah.
Yeah, save model, model name. So now you want to say you want to use some other model, so you will write uh, at the rate name dot model. So it will load that particular model.
Okay. Okay.
So by the way, this is the AGN, right?
Yes.
Oh, oh. So so what kind of, like, after fitting this, what parameter you will find out? So
I don't know yet. I mean, this is just this was given to me just to get familiar with the XSPEC in
oh,
general,
okay, okay,
but the actual model I haven't studied it well yet, so I'm still learning about it.
okay, okay, good. I know. Okay, you can ask me, like, if you find, if you want to know some yeah, some comment, you can ask me.
Okay. Yeah.
I think this is good. So I have told you how to freeze some parameter, right?
Yes.
Yeah, that may be sometime important, so you have to use that quite frequently.
Okay.
Okay.
Okay. Then
But
that that would be that
anything
would
else?
be enough. Okay.
Uh,
No, so I haven't really done much of it yet, so I don't have many doubts yet.
okay.
But I can ask you
Yeah,
if
sure.
that's okay.
But that if you know what's the problem is, I don't have any answer to that problem, that why expect uh,
Oh, no
chi-square
worry.
is not reliable. We're getting some covariance problem, no?
Yeah.
So if you find out the answer to it, just let me know. I also don't know properly why it's.
Okay. Yes.
Okay. Bye.
Okay then. Thanks.
Bye.
I'll. Okay.
Bye.
So
Yeah.
if you have recorded this, are you going to save it somewhere? You can.
Yeah,
Send
actually,
it.
one of my friend also asked how to use XSpec, so I just
Okay.
that's why I recorded it.
Okay. If you happen to put it on Drive, then do
Yeah,
share
yeah,
with me.
yeah, sure, sure.
Okay.
Hmm.
Thank you. Bye.